All right, ladies and gentlemen. When I did a video conference with about 19 of you guys just to try out the video conferencing to see if it worked, several of you asked for kinetic molecular theory, KMT, and I said we went over most of this in class. So this is just a little review. I'm going to go through it pretty quickly. But this is the PowerPoint that we used in class, and you have notes on it in your journal already. Okay, so we described basic principles of the kinetic theory of gas, explained where pressure came from and its effects. So the word kinetic means motion, and that means that all matter is in constant motion, even solids. Remember I said that the um, excuse me, the solids in your desk were still vibrating slowly, you just don't see it. Okay, so the word gas comes from the Greek word chaos. Hopefully some of this is ringing a bell. Um, so gases are made up of tiny particles that have very little volume, but it is there. Okay, gas particles are far apart. They do not attract or repel each other. There is an attractive force between particles of solids and liquids, though. All right, particles move independently of each other. So this is why gases expand and fill their container. All right, the word diffuse means to move out. So remember we did this in the class, and I showed you some perfume, and it went diffused across, and then we had effusion, which was coming out a tiny little hole. Okay, and like kind of like when you have a nail in your tire and the air's kind of leaking out. Okay, gases have no definite volume or shape. Gas particles move very fast. Um, so when a bottle of ammonia is open, the entire room doesn't smell right away, but eventually, as it trickles through diffusion, it will. Okay, and that's because they're moving in straight lines until like they collide into each other. Okay, so particles move in a straight line until they collide with one another and then change directions and repeat. So all collisions between gas particles are elastic, that they do not stick together. Okay, can be transferred. Kinetic energy is transferred from one particle to another, but is never lost. Gas pressure is caused by the collisions with each other and the walls of the container. And as the collisions increase, the pressure will increase. And we saw that in our lab activities where we got to do all the little stations. Okay. More collisions will result if there are more particles in the space. That's, again, Avogadro's law. As temperature increases, pressure will increase. All right. And that was temperature and pressure was Gay-Lussac. Sorry. This is when we were doing we went over this before we went into get in the bag. I think we did this right before. A region of space where no gas pressure is exerted is called a vacuum, and gas pressure is equal to 0, so there are no collisions. And remember the peeps, remember Marie and Pierre? Okay. Atmospheric pressure is the pressure caused by the air in the atmosphere. It depends on weather and altitude changes. As altitude increases, atmospheric pressure decreases. Air gets thinner as you go up, and that's why the balloon, when the guy jumped out of the balloon, the weather balloon that went up to the edge of space, he got up to the top and it started to expand, and then he jumped out. You know, it started out like this, and then it got really big by the time he jumped out of it. All right, standard pressure is the average pressure as measured at sea level. We actually have 5 quantities of pressure. 1 atmosphere, and these are the ones that I show you in ideal again, the 5 of them. I'm going to show you 3 right now. Atmospheric pressure, millimeters of mercury, and kilopascals. We also have PSI, pounds per square inch, and then we also have torr, which is torricellis. Okay. Oh, and just so you write this down if you haven't already got it, but 760 torr is equal to 1 atmosphere. 14.69 psi is equal to 1 atmosphere. Those are the conversion factors. Okay. So measuring atmospheric pressure is used with the barometer. Okay. So we use that barometer, and that's a diagram right there. So Guys, look at the KMT. Basically, KMT says that all particles are in motion. They move randomly. They have elastic collisions. If there's anything that comes up that I did not cover or you forgot, please email me or join the video discussions when I have them. Okay, I'm gonna probably post some more videos on anything that people have problems with. Okay, so have a good day.